to the session on size matters, where we're looking at the many ways in which an application modernization project is affected by the application size. So I'm wondering, of everyone in the audience, how many of you came here with the idea that we'll be talking about monolith to microservices? Okay, well that's about 7%. Interesting, thank you. So in my presentation today, I'll be looking at some research from, well, some original research that we've done in my company, and also at some research that we've done, well, that universities have done, so research from outside our company. So we've heard a lot about continuous modernization, and I'm sorry, I'm having a challenge concentrating on what I'm saying, because every time I say something, there's a short delay, and then I hear my own voice again, and it's much louder. Let's see how this goes. This might not go very well, and I might just take off my microphone and shout at you in a while if it. Okay, so we've heard a lot about continuous modernization. Okay, now I'm going to try this. Do you think I can try this without the microphone? Is that going to work? It's going to drive me nuts. Okay, I'm going to try this. Can you hear me? Can you guys hear me? Is that all right? Is it okay if I continue? Oh my God. They say no. Okay. I can't believe this. Okay. All right. We're going to try it anyway. Okay, so we've heard a lot about continuous modernization. So there's, I think for many companies, continuous modernization is an aspirational goal, but for many it's kind of out of reach. Some companies are successful with it, but even companies that are successful with continuous modernization, there comes a time when you have a modernization that's so highly invasive or discontinuous that you really need to look at modernization as a project. So a project that has a moment it begins, a moment that it ends, and resources that you have to allocate to the project. And of course, allocating resources to a project, this always means money, and inevitably, someone's going to be asking, well, what does it cost? What will the modernization cost? And I think inevitably also developers also get involved in answering this question, and they get involved in providing estimates. But there's some problems with that, of course, because not all developers are very good at making estimations. Not all developers have a lot of experience in estimating. And I guess most importantly, discontinuous modernization is very often unprecedented. So it's not something that you've done before. I mean, if you migrate your Java application to Spring Boot 3, well, you're only going to do this once. So any lessons learned from your project to migrate to Spring Boot 3, you're not going to be able to apply these in subsequent projects, for example, or subsequent modernizations of that application. So for developers, it's very useful to be able to get some kind of orientation in this question, or in answering this question. And there is actually a way to get some orientation, and that is to look at the worst case scenario. So there's a worst case scenario that you can take into account, that is really that you need to throw your existing application away, and you need to create a new one from scratch. And obviously, this isn't what we want to do, but sometimes it's a useful, well, it's a useful way to give you some orientation, and it also gives you a baseline. There's actually some very simple rules of thumb that you can use to compute the cost of redeveloping an application. This is the replacement cost. And there's lots of researchers that have done empirical studies around this topic, and they've come up with some very simple rules of thumb that you can apply. So as a developer, you might not have access to the same information that your management has, but something you have access to that management might not have access to is the number of lines of code that are in your existing application. So the rule of thumb is actually really simple. You take the number of lines of code in your application and you multiply it by about 19 euros. And here's some examples. So apply a 50,000 line of code application, multiply that by 19 euros, and then you get 950,000 euros. And then if there's a 125,000 line of code application, well, you use the same formula and you'd get 2.37 million. What's particularly interesting about this is, besides the fact that it's very simple, is the fact that this formula is very old. It's actually so old that it's older than Java itself, but this is actually, well, certainly I've found this in my interactions with the organizations that I'm working with, is that it's very relevant. This is the feedback that I get, is that this formula is actually very relevant and is close to the actual number. We've seen that in the architecture-driven modernization works by Ulrich and Nulcom. There's some books that they've written where they've looked at this in detail, and yeah, they support this as well. So this is something that you can use. All right. So now I've talked about money, so I can now introduce myself. So my name is Ben Wilson. I'm a product manager at Vaadin. I'm the newest product manager in the team. Actually, before I joined the PM team, I was working in the services department, and I was working with customers, doing a lot of hands-on work, helping them to be successful, migrating their applications to the latest Vaadin platforms. And Vaadin itself, so we're actually here today. We have a booth. We're sponsors of this event. So Vaadin framework builds a framework for building web applications that leverage Java. So if you have good Java skills, you can actually be madly productive in creating data-driven applications with the two Vaadin frameworks, Hilla and Flow. All right, so in the time that I took to introduce myself and also introduce Vaadin, I guess many of you were probably thinking about the $20 or 19 euros per line of code rule of thumb that we were looking at. And some of you might be thinking that this is really simple, and probably you're thinking that, well, bearing in mind that the implication of this, the fact that this would be a linear function, is that every additional line of code that you're adding to an application, regardless of the size of the application, is going to cost the exact same amount in order to produce. And probably you're thinking that this doesn't really make a lot of sense, because you sense that the effort to create an application, that this is going to rise faster and faster as an application gets larger. And you'd be correct. So there's actually 3 different things that co-vary with the application size, and they all vary according to a different function. So more, I mean, there's effort, yes, there's also cost, and there's also duration. So more empirical studies by more researchers at more universities have been looking at all of these, and we have, well, actually, we can distinguish between these 3. And one is clearly superlinear, one is sublinear, and the cost, as we were saying, appears to be linear. So effort is superlinear, so this is going to accelerate. This will go up faster and faster as you have a larger application. Duration, so project duration, this is going to go up, but it's going to slow down as you have a larger application. And the thinking there is that, yeah, with a larger application, you have more work to do, and you'll be able to compress more work, you'll be able to do more things in parallel with more members of your team as you have a larger application, more to work on. Of course, this exposes you to some risks because, you know, with a larger application, with a larger team size, any kind of hiccup, anything that would be slowing you down, of course, is involving increasing effort. There's formula for these. So the formulas look like this. This is the general format. So we already looked at costing. So X times line of code, where X is $20. But we also have effort and duration, and both of these have some parameters, a bit more complicated than cost, but still a function of thousands of lines of code. Looking at effort, there's an A there. So the A that you're multiplying by k log to the power of v. This is really a function of your team and how what the attributes of the team and how they've been working together. So, for example, does the team have experience with the languages that you're using in developing this application? That's one factor. Another one would be, has the company have the people in the team, do they have a lot of experience working together? That's another factor that you can add to this A, and then you'd arrive at your function there. And then B and D over there on duration. According to the studies, you know, and the many studies that they've done on many empirical studies, they come to a 1.2 as the coefficient for B, and then 0.4 as the exponent for D. Okay. So we can ask, well, does this apply to all applications? And the answer, of course, is going to be no. It's certain applications that these numbers are going to apply to. Obviously, if you're looking at something like the automated control systems of the Mars rover, the cost per line of code is going to be much higher than $20. But to get some insight into what kind of applications these would be applicable to, we're now going to switch to some research from Vaadin itself, and specifically some of the results that we've had from the migration assessments that we've done in the past 5 years. Okay, first I'll introduce the migration assessments at Vaadin and what sort of work that we've done, and what characteristics that these applications have. So we have over 75 Java applications that we've looked at during this period, and actually most of these have been web applications, and the purpose of the modernization was to move to the latest version of the Vaadin APIs in order to be compatible with the latest browser standards. 10% of these were desktop applications. And really, the objective there was to simply web-enable these applications. So we're talking about desktop Java. And all of these were monolith to monolith. So these were very simple technical transformations that the companies were aiming to achieve with their modernization. They were not looking to split these up into pieces. Then, of course, we have the analysis by country. So we're here in Cologne, and actually most of the applications have come from around this very spot where we are right now. So lots from Germany, lots from Switzerland, France, and Belgium. And of course, also the USA. All right. So we're aiming to understand more about the size of applications and how this might impact modernization. So first, let's try to understand what these applications are like, and in terms of their size. So if we were to put all of these 75 applications in assorted order according to their size, then we'd actually be able to see a normal distribution appearing. And let's say the smallest one is about 10,000 lines of code, and the largest one is 12 million. And how we would split this up in order to create this normal distribution, we'd draw some cutoffs here. So there's the 60,000 lines of code cutoff that would identify the very smallest applications. And then we'd have 250,000 lines of code that splits everything into half. And then we have the 1 million line of code to 18 million lines of code, 12 million lines of code that comprise the final 16%. That's the final slice. Let's take a bit more deep, let's take a closer look into the smallest slice, and we'll see just what kind of applications are these. So the smallest slice, some samples are a Department of Education database on students. We have, it's in the country somewhere. We have truck driver dispatching, and we have internal HR portal for employees. If I were to generalize, I would say what these applications have in common, especially since they're very small, or they're smaller applications, is that the value of the application to the organizations that use them isn't really in the functional requirements, because the functionality is quite simple. The lines of code are very few. The value is much more outside the functional requirements. And if we look at some of these, we'll see the example. For example, the internal HR portal for employees, they have a large number of users. So they have about over 20,000 users inside the company using this application. And the Department of Education database on students, where it's keeping track of all the personal data of kids, basically, in the country. Obviously, security is a big concern. Truck driver dispatching, that's another one. And here, that would be availability. So high availability as a non-functional requirement would be a key there. All right. The second slice, we have different kinds of applications. So we have clinical trial monitoring. We have weather events and airplane insurance. We have government subsidy management, and we have laboratory accessioning. What these applications have in common, I would say, would be that they're a narrow, specialized part of a broader domain. So for example, the laboratory accessioning. What's happening with laboratory accessioning is that it's a part of the laboratory management information system workflow and it's the first step where a laboratory is receiving samples that need to be tested or treated, and the laboratory needs to catalog what it is that they've received, and they need to do things like printing barcodes and attaching the barcodes to the samples, and making sure they're stored at the right temperature that they need to be stored in, and they keep track of that. So obviously a laboratory information management system is going to have many functions, not just the accessioning. So as I said, this is a an example of a narrow, specialized part of a broader domain. The third slice, where we have between 250,000 and 1 million, there we have multiple narrow specialized parts of a broader domain. So we have things like record and document management, aircraft maintenance, pension insurance, oil and gas pipeline management. These would be examples. And then the largest slice, or the slice with the largest applications, there's really two things here. We have applications that need to be customized for different customers or perhaps different regions. And here we see this in particular with the municipal governments. So, you know, different cities or different regions or different counties might have different laws and different practices. And so anyone who's selling a solution in this area would need to customize quite heavily their core solution. Same thing for HR throughout Europe. You know, different European countries will have different laws, but also different customs around compensation and other things. So that, I mean, the lines of code can stack up once you bear in mind the fact that there's a lot of customization. The second part is where there's just a really huge domain, and I think also characteristic is that there's a lot of regulation. So if you look at core banking, hospital management, social housing, not only are these vast domains, but there's also a lot of government regulation and compliance that these software solutions need to adhere to. So taking into account the legislation and the changing legislation, and you know, legislation can be quite complicated. You can really get a lot of lines of code this way as well. Okay, so we just looked at 4 different slices of you know, sample Java applications that companies are modernizing, and we saw what the characteristics were. But we could ask, well, how does this affect the modernization plans? So I'll start at the beginning again. So with the slice of the smallest applications, we've got really things that are not very complicated, I think not very specialized, and you know, with the value simply being outside of the functional requirements, you know, creating a copy of the functional requirements or fulfilling the functional requirements isn't much of a challenge. So if you have someone, let's say what I like to call a random smart person, you could put the documentation of these applications into their hands and say, yeah, could you redevelop this one? And they would probably be successful. They don't, I mean, there's not a lot of domain knowledge that they would need in order to create something that would be suitable for testing. And that's really not the case once you get beyond the 60,000 lines of code, because here we start to have a narrow specialized part of a broader domain, and the skills that you need in order to understand and verify that the features are complete are, yeah, well, it's specialized. It's not just a random smart person that you would be able to use there. You would need to have someone available who at the very least could answer questions and give guidance. The third slice, where you have multiple narrow specialized parts of a broader domain, it just continues that. So we would need several specialists, whereas previously we just needed one specialist. I would say you would need several specialists in order to deal with the different specialized parts of this broader domain. And then with the largest one, well, here it becomes very difficult because you would practically need to have some kind of a qualification as a developer to even understand what the documentation is saying, and certainly when it comes to customization, not having the knowledge of what the customer requirements have been, this is going to make it difficult for you to be productive. So here we definitely need the expertise, and we need to plan accordingly. We need to formally make a plan for certainly everything over the 250,000 lines of code cut off there. We would really need to plan on the availability of the experts. Okay. So that was it about size of application and expert skills that you would need in order to run the modernization. We're going to take a step sideways and look at the results from the Vaadin 2023 Java Community Survey, where we did a survey in the Java ecosystem about their modernization plans. So one thing that we found is, we had quite a number of respondents there. The results were actually shared in the Vaadin State of Java in the Enterprise Report of 2023. So one of the things that we tracked was, well, where are these applications? And it looks like almost 20% are still on desktop. So there's still some Java desktop out there. But the majority, by far the majority, so over 80% is definitely a web application. And organizations were kind of split in their perception of Java apps needing modernization. So over half of all the respondents said that they think that the Java applications don't need modernization at the moment, and the other half saying that they do. There was some variance by region, so we were looking at the Americas, also at Europe and the rest of the world. So the Americans seemed to be the most optimistic that they did not require modernization of their applications. Europe was, well, behind them, close to 50-50, and the rest of the world, well, it was the opposite. So most respondents said that their applications did need modernization. Then we also looked at the modernization drivers. So what was driving the company's decision to modernize their Java applications. And we had this list as a result. So of course this is the Java community, and I suspect that most of the people answering this survey were developers, and that maintainability was a primary concern for them. So maintainability came out on top. And following that were, of course, the security risks and cost to maintain, and the risk posed by working with or depending on old technologies. Okay, I'll take a step back sideways, back into more of the assessment findings. So we've actually seen a number of companies doing migration assessments. I think this became quite popular with the move to cloud movement. So many companies were doing, well, migration assessments to see like what would the impact be if they moved their application to cloud, and well, there are quite a number of vendors doing this. One way in which the Vaadin migration assessments were kind of different from, I think, most of the rehosting oriented migration assessments perhaps from other vendors, was that we were actually looking at the Vaadin level. So we weren't just looking at the POM and seeing what dependencies does this project have, but we were actually looking at the Java and seeing at the API call and also at the component level to see which components and APIs were being accessed. So our migration assessments provided lots of very detailed information about the way that the applications are using the APIs, or let's say the libraries that the customer is trying to move away from. And yeah, these are 4 samples taken from well, past modernization assessments that we did. And it's showing the classes, or the top 30 classes, that declare the methods that the application is invoking. So the APIs that the application is using of the library, and then grouped by class in which they're declared. So we get overviews that look like that. So what's quite remarkable about this is that in all of these, and this is actually a pattern that we see repeating for the APIs, is that these charts always have a very high peak and a very long tail. So this is typical of what you would see with a log normal distribution, or perhaps a Pareto distribution. So Pareto was an economist, and he was the one who came up with the 80-20 rule. And perhaps you've been able to see this in your own organizations, that 80% of your revenues are coming from 20% of your customers, or perhaps 80% of your users are only using 20% of the features of your application. So this is sort of a universal law. But we were looking at this also to see the relationship, or trying to understand the relationship between the distinct API calls that the applications were depending on, and comparing this with the total calls. And we can see that this was actually a pattern that we saw everywhere. And this is just showing the methods invoked. So this is the API usage, but we also have the types and the way that the types were used. And here's some samples that show from the API, or let's say from the library, what types the application is subclassing. And we see the same pattern emerging. So there is a tall peak and a long tail, and yeah, this repeats. We see the same thing for expression evaluation. So what type is being returned from a method invocation? We also see it for cast expressions, so types being used in cast expressions. And we see the same Pareto-looking graphs. And then also even simply when accessing constants, so compile time constants in the API, we have the same pattern emerging. So we could wonder, is this actually 80-20 also? And is 80-20 a constant across all applications, and is it independent of the size of the application? So if 80-20 were a constant, and you know, and completely independent of the size of applications, then we could expect to see a graph something like this, that's showing the number of the percent of distinct API invocations that you need in order to make up 80% of the total invocations. And then here ordered by line of code of the application. So we're actually using a logarithmic scale here. We don't have a linear scale. This is a logarithmic scale, and we see, well, it really does correspond to the first bell curve that I presented a while ago, with the 250 mark more or less in the middle. It turned out that this is not at all what the data looks like, and the actual data looks like this. So I want to share this with you, just to share, you know, what the impact is of different applications and the way that they're, I think, architected. I think architecture is a really key point that we can discuss here. So first of all, let's just look at the axes here. So the x-axis is just thousands of lines of code. Every dot is an application. And here the y-axis is the percent of distinct API invocations. And we actually see that there is not a single application in the sample that is reaching 80-20. There isn't one 8019, there isn't one 8018. There's actually a big white space all around the 8020. At this point here, this is an 8026. This point here is an 8024, and so on. So we have this big white space. We do have a nice a nice trend that's decreasing here, so that progressively fewer distinct APIs being called are needed to show the top 80% of the total invocations. And it goes all the way down to 4 over here, which is quite spectacular. All right. Something that's quite remarkable about this is this big white space that we have in the upper right-hand corner. So essentially, there is no application larger than 250,000 lines of code that has an API concentration that's higher than 12. A lot of this has to do with architecture. So if you have an architecture that naturally leads developers to use a small number of APIs, and that you get some consistency that way, then two things are going to happen. First of all, you will have an application that can grow, as the data is showing here, but you're also going to have an application that's easier to modernize because of the consistency that you have. All right. If we reintroduce those cutoff points that we saw previously, then the cutoff points look like this. So that's the 60,000 lines of code, the 250, and then the 1 million lines of code. The reason for being so excited about this is really has to do with, because this is Java and because Java is statically typed, and there's so many things that we can do at compile time with a Java application, so many ways that we can modernize it. We can also consider whether it's cost effective to invest in creating automated refactoring or doing automated refactoring. So we're comparing here an 8026 with an 85. Well, let's just take a look. What does this look like if we represent it as a bar chart? Well, the one on the right with the 85, it's a much better situation for doing automated refactoring, because if you consider what this bar chart is showing, it's showing that there's essentially 6 components. With just 6 components, you have 66% of your total application. So being able to focus your automated transformation in investment efforts on those 6, you can actually get a whole lot accomplished. But if you compare that with the situation on the left, where it's 8026, then the top 6 is not even, it's only going to give you about 33% of the total. So that's a much less interesting story and less interesting for investing in automated modernization. All right, I think we're about through with the time. Does anyone have any questions? Yes, we have a question.
Maybe you have some confirmation of this estimation of the costs per line of code. You've shown that it's like between 18 and 20 euros. Like, do you have some, I don't know, empirical studies or something like this that show how close this estimation is?
Yes. So for anyone who didn't hear the question was related to one of the first slides in the presentation. It was about the rule of thumb of $20 per line of code. So that is here. Okay, so all of this is actually based on empirical studies. I didn't actually do the empirical studies. There's researchers in universities all over the world who have been studying actual empirical cases of software development, and they've come up with this. I can say that I myself, that I have seen this confirmed, and my customers have told me that. The reactions have been kind of funny. So when I am speaking with my customer and they've given me an application that has 125,000 lines of code, and I told them, well, probably you paid about 2.37 million euros to create this application. Well, the feedback that I've got has been confirming. It's been like, yeah, that's pretty much right. They don't always have very exact figures, but sometimes they do. So yes, I do. I mean, I have had confirmation from actual people and not just read the university research. All right. Was there any other questions? Otherwise, we'll probably need to end this now and let you get to your next session. Yes? Okay, then thank you very much.